Hi everybody. First I would like to say that you have to invite Allah subhanahu wa ta'ala to protect the Egyptians and the Egypt against virus corona. Allah said in the Quran, ادخلوا مصر إن شاء الله آمنين. So Allah will protect the Egyptians and the Egypt against any crisis, against any disease. Thanks for God. Okay, you know that you have a holidays for 2 weeks, and the university told us to record 2 lectures to learn from YouTube the subjects that we will explain in these 2 lectures. This is the first lecture, which deals with measures of central tendency. In this chapter, we provide several numerical measures that represent additional alternatives for summarizing data set consisting of a single variable. Okay, so as we explained before, summarizing data may be in tables like frequency tables, like relative frequency tables, and percent tables. This is the first type of summarizing data set. And we also said that you can summarize data in shape of graphical shapes, graphical figures, according to the type of data set. When the data are qualitative, you have to use bar chart, as we said before, or pie chart, as we said. So, as we explained, bar and boy may be in 2 dimension or 3 dimension, but bar chart can be drawn vertically or horizontally, and we explained how to draw these figures by hand and by MATLAB programs using the functions bar or by 3, bar h, or by 3h. So we have 4 functions to draw a bar graph. You know that the bar graph is a rectangles. Every one represents the frequency of the qualitative data. And for quantitative data, we explained that the graphs may be in the shape of histogram, line chart for time series data, and ogive when dealing with cumulative frequency tables, and so on. So, in addition to the 2 types of summarizing the data we explained before, tables or graphs, there are many measures to represent a data summary. one of these measures is called measures of central tendency. So measures of central tendency is the third method of summarizing data set. Okay, so measures usually represent all data summary in one figure or one number. For example, you can say the average score of students is 15 scores. So this is one integer, one number. Okay, so the third method of summarizing the data is called summary measures. One of these measures is measures of central tendency. Okay, now look, when a data contains more than one variable, the same numerical measures can be calculated separately for each variable. Okay, as we said before in the first chapter, if the measures are calculated for the sample data, they are called sample statistics. Sample statistics. If the measures are computed for a population data, they are called population parameters. So you have to differentiate between sample statistics and population parameters. Okay? The measure of central tendency, also called measure of location, and gives the central of the histogram or the frequency distribution curve. The most common measures of location are the mean, the median, and the mode. However, other measures of central tendency, such as the trimmed mean, the weighted mean, the combined mean, and geometric mean, in addition to the harmonic mean, and these measures will explain in this chapter. A measure of position determines the position of single value in relation to the other values in a sample or a population dataset. There are many measures of position, like quartiles, deciles, quintiles, and percentiles. Okay, so we have measures for central tendency in addition to some measures for position. Okay, first, the measures of central tendency. The first and the very important measure of central tendency is the mean. Okay, the mean, also called the average or the arithmetic mean. It is the most important and frequent used measures of central location or tendency. Okay, Now we will explain how can we compute the mean for sample data and population data. The mean for sample data is denoted by X bar, okay, like this. If the data are for a population, the mean is denoted by mu. Mu is a Greek letter and called a parameter, but X bar is called statistic. So you have to differentiate between the sample statistic and the population parameter. So how can we compute the mean for a sample and for a population? Okay? Thus, the mean for population data is called mu, and as I said, mu is a parameter. Mu is a parameter. Mu equals sigma x over n. Here we use the capital letters, but when dealing with sample data, we use small letters. The mean for sample data is X bar, which equal sigma x over n. These are small letters, but for population, we use usually a capital letters. So, mathematically, the sample mean looks like the population mean. All of them equal sigma x over n. X is the observation, so sigma x is the summation of all observations, and n is the number of observations, number of data sets which we deal with. Okay? So, in this formula, or the formula of computing the mean, the numerator is the sum of values of the n measurements. That is, sigma x equal x1 plus x2 plus extra to reach x of n. With the Greek letter x, sigma, is a summation sign. So, because we have two types of letters, the Greek sigma is a summation sign, but we have another sigma which represent the standard deviation. So you have to differentiate between a great sigma and small sigma. Okay? Now, when using the MATLAB program, okay, to compute the mean of the sample or of the population, we have to use the function mean. So the function mean gives us the arithmetic mean of the sample or the population. When using this function, the syntax may be m equal mean of a, or m equal mean of a and them, or m equal mean of A and them, or mean of A, and non-flag. We will explain the meaning of non-flag later. Prescription. So the interpretation of these commands or these syntaxes as follow. The first syntax, M equal mean of A, returns the mean of the elements of A along the first array dimension whose size does not equal 1. So this means that the size of data set must more than 1. You cannot compute the mean for only one observations. This is not correct. You have to compute the mean for more than one element at least. If A is a vector, then mean of A returns the mean of the elements. Vector here means that the data set given in the shape of one row of data, not a matrix, one variable in one row. So the observation must be ranked as a row, not a matrix. Okay? So when the data set are some observation or some elements given in a row form, the mean is one measure, one number. Okay? But if A is a matrix, then mean returns a row vector containing the mean of each column. Okay? So if A is a matrix, contains some columns, so the mean will be one number for every column. So the result will be a vector containing the means of all columns, right? M equal mean of A and them. If A is a matrix, so we can compute the mean for columns or for rows. The default is computing the mean for columns. So this type called them means that you have to specify the dimension of the matrix you want to compute the mean. If you want to compute the mean for columns, this is the default. So you can write here 1 for columns, or you can use mean of A without any other integers, any other dimension. Okay, so the default is mean of A for the columns of the matrix. But if you want to compute the mean of rows, you have to use this syntax, this command, and put them equal to. Equal to means compute the means of the rows of the matrix. Okay? So if you want the mean of columns, you can write mean of A without any dimension, or you can write A with dimension 1. Okay? But if you want to compute the mean for rows, so you have to use them equal to. So you will substitute this them with 2 when using rows of the matrix, right? Okay. So if A is a matrix, then mean of A and the 2 is a column vector containing the mean of each row. So the result or the answer when using them equal 1 or mean of A only without dimension, the result will be in shape of a row containing elements. Every element represents the mean of one column. Okay? But if you use the mean of A and 2, I mean when you want to compute the mean for rows of the matrix, the result will be in the shape of column vector, not a row vector like the them equal 1 or without them. Okay, so the result here or the answer here when using mean of A and the 2 is a column vector, right? Okay. The mean of something, any of the above formula, any of the above commands, and non-flag specifies whether to include or omit nans. Nans here means not a number, not a number. Okay, so this command can be used when you have a missing value, not a number. Here mere mean you have missed some observations. So this command have two types. First, include nan, and the second, omit nan. Include nan means count the number of observations included the missing values or the missed values. Okay, but mean of A and the omit nan means ignore or execute the values which is not included in the data set, right? So we will not use this command in in second year, but we can use it in third year or fourth year. Okay, just you have to know that name flag or nan is used when we have missed values in the data set, and this is not our interest in this phase. Example 1. The following data represent the net profit of 6 firms by millions of Egyptian pounds during the year 2015. These are 6 observations, and we want to compute the mean of all these observations. Find the population mean means it's not a sample, it's not a part of population, but these are all elements in the population, all elements. So you have to use the formula for population. Using the manual solution or solving by hand, you put mu equals sigma x over n, where n equals 6, and x is the observation. The summation of all 6 observations, these observations must be collected and divided by the number of these observations, like this. So the result will be 1 over 6 multiplied by the summation of all values, like this. The summation will be 120 and divided by 6, so the result will be 20. So the mean of this population is 20 million Egyptian pounds. By MATLAB or by programs, we have to use the function mean, or maybe use the function sum and the length, as you see. So it's better to use mean of x. This is a function, but if you want to emphasize that the result is correct, get the summation of x and divide by the length of x. The length of x means the number of observations written in the program. Okay, so you have to enter the data like this. Assume that x represents the data set, so x equal a square bracket, then write the observations and use a blank or a comma, like this. So this is the comma. You can replace it by a blank. So it's better to write comma to be sure that everything is okay when entering these data. And here the semicolon means that you want to hide the data. Hide the data, okay? So mu, you cannot use here the Greek letter mu. Greek letter mu. You must write it. Okay? Mu instead of the Greek letter mu equal mean of x. Mean of x. Okay, the result is mu equal 20. So just write this command and press enter. The result will be mu equal 20. If you want to know the length of x, that means that the number of data entered in x, use the command n equal length of x. Here n can be replaced by any other letter or name or anything. Never mind about this letter which written before the equal sign. Okay, so the length of x equal 6. To be sure that the mean of x equal sum of x over n or over the length of x, you can use this command. Okay, so this command looks like what you do using your calculator. Sum of x means the summation of x divided by the length of x, which is the number of observation. Okay, but you have to use this one. You have to use this syntax. Okay, right. Example 2. Assume that the monthly salaries of a sample of 5 employees in a firm during the year 2015 are these observations. Okay, represent the monthly salaries of the employees. Compute the sample mean of the salaries. Okay, by hand, use the symbol x bar here because this data represents a sample, not a population. Okay, but sigma x over n is the same way for computing the sample mean or the population mean. Okay, so the formula is the same, but the letter is not the same. Mu for population and x bar for a sample. Okay, so x bar is a statistic extracted from a sample, and mu is a parameter extracted from a population data. That's the difference between mu and x bar. By MATLAB, we have to enter the data like this. Okay, as we said before. Then x bar, you cannot write here x and bar above x. Okay, so you can use x underscore bar instead of x and bar. Equal mean of x. This is the function mean, and this is the syntax or the command of computing the mean for a simple data or for a population data according to the type of data set. So x bar equal 1,400 pounds. Okay? Or if you want to be sure that the mean is correct, the mean is right, you can say, you can use sum x divided by length of x, as we said before. Now look at the two results for the two syntaxes or the two commands, 1,400 and 1,400. Okay? The second measure of central tendency is called the weighted mean. The weighted mean. Okay. In some cases, certain values in a data set may be considered more important than other values. For example, to determine students' grades or marks in a specific course, an instructor may assign a weight to the final exam twice as much as to each of the other exams. Okay? In such cases, it's more appropriate to use the weighted mean. Okay? So you have to understand that if you're given a weight for some observations, you have to use the weighted mean instead of the mean, right? Okay, but the mean is computed for observations with the same weights, okay? If you have a data set with different weights, you have to use weighted mean instead of mean. If you computed the mean in this case, it's wrong measure for central tendency. The right measure in this case is the weighted mean, not the mean. Okay? If the values x1, x2, and extra are assigned by weights W1, W2, and extra respectively, the weighted mean is computed as follows. WX bar means the weighted mean for a sample data equal sigma WX over sigma W. So you have to multiply every weight by the corresponding X and divide by the summation of weights, the summation of all weights given corresponding to the data set. Example 3. Assume that weight of each monthly exam is 10%. Okay? The weight of the midterm exam is 20%. And the weight of the final exam is 50%. Now look, the weights are different. Monthly exam is 10, midterm exam is 20%, and the final exam is 50%. So because the weights are different, you have to use the weighted mean instead of the mean. Find the weighted mean for a student who has 78 and 82 and 85 for the 3 months exam, and finally 80 for the midterm exam, and 70 for the final exam, right? Okay, the solution will be manual solution or by hand. You have to multiply every weight by the score corresponding to this weight. So Wx bar equal sigma W x divided by sigma W. Okay, so 80 must be multiplied by 20. 20 is a midterm weight. Okay, so 80 is the score of the midterm, and 20% is the weight of the midterm exam, plus 82 multiplied by 10. 10 is the weight of the monthly exam. So we have 3 monthly exams. Every score must be multiplied by 10. Okay, so the first monthly score is 82 multiplied by 10, and 85 multiplied by 10 also, and the third monthly exam or quiz is 78 multiplied by 10, and the final exam, the score of the final exam is 70 multiplied by 50, which is the weight of the final exam. All of these multiplications must be collected together and divided by the summation of weights. Summation of weights are 20 plus 10 plus 10 plus 10 plus 50. Okay, all weights equal 100. Okay, so the summation of the numerator is 7,550 divided by 100. So the result will be 75.5. So the mean is, or the weighted mean is 75.5. Okay, so this is the mean of the scores for all exams: final exams, midterm exam, and the 3 quizzes are 3 monthly exams. Okay, by MATLAB there is no function for weighted mean, but we will use another function to compute the weighted mean like this. Okay, so the data is written as a row vector like this: x equal square brackets and the observations, and the weights must be written in the same way like this. This is the weight of midterm, and the weight of the monthly exams, and the weight of the final exam. Okay, then here x bar, or the weighted mean here, equal sum of x multiplied by W. X is the scores and the W is the weight. Okay, so when multiplying a row vector by row vectors, we have to use the dot and the asterisk, okay, according to MATLAB program. Okay, so you have to multiply the vector x by the vector w and divide by the sum of w, the sum of weights. Okay, so because we have not a function or a syntax for weighted mean, we can use the program as a calculator, but here the program multiply a vector by a vector. You cannot multiply a vector by a vector using calculator. Okay, so by hand you will take a lot of time when multiplying one vector by one vector, but using the program you can get the result sooner, and by using a functions like this. Okay, so the result will be 75.5 score, the same result using manual solution. Okay, so the third measure is called combined mean. So what's the difference between weighted mean and combined mean? When dealing with more than one sample of data set, you can compute the combined mean of all samples. Okay, so we explained the weighted mean is used when you have a weights for the observations, but here the combined mean is used when you have more than one sample, and you must compute one mean for every sample, and also how to get the combined mean for all samples. This is the difference between combined mean and the weighted mean. So combined mean is computed for a lot of samples, but the weighted mean is computed for only one sample with different weights, for all observations in the sample, right? So the combined mean for two or more data set is computed by the following formula. X bar, here X bar is the mean of all samples, not for one sample, like the mean. Okay, so you can say that this is must denoted by X bar bar, not X bar, but we use X bar here to simplify the computation or the concept of combined mean. X bar equal sigma ni x bar I divided by sigma ni. So this formula looks like the formula of weighted mean, but here X bar is not an observation. X bar is a mean of sample. So for every sample you have to compute X bar, and N1 or Ni is the number of samples. It looks like the weights in the weighted mean, right? So the size of samples, you can concern it as a weight, right? So you have to multiply every mean for every sample by the size of this sample and get the summation of all X bars for all samples and divide by sigma n, which means the size of all samples. So if you want to compare the weighted mean with the combined mean, you can concern n here is the weights, ni means wi. So instead of wi, put sigma ni multiplied by x bar I and divide by sigma ni. So instead of w, use n in case of combined mean, right? So example 4 will explain this idea. I mean the combined mean. Suppose a sample of 5 statistics books give a mean of price £50. Okay, this is the first type of books. 5 statistics books give a mean of 50 Egyptian pounds. Okay, a sample of 8 financial mathematics books gave a mean price of 45 pounds, and a sample of 7 accounting books gave a mean of 60 Egyptian pounds. So we have 3 types of books. Okay, not 3, 5 types of books of statistics. Okay, one price 50 and the other price 45 and the third of 60. Okay, find the combined mean. Find the combined mean. Okay, here's the first type. Sample size is 5 and the second sample is 8 and the third is 7. Okay, so you can consider the sample size as a weight. So the first weight is 5, the second weight is 7, the third weight is 7, the second is 8 again, the third weight is 7. Okay, and the price of the first one is 50, the price of second one is 45, and the price of the third one is 60. Now to compute the combined mean by hand, use x bar equal sigma ni multiplied by x bar I and divide by the size of all samples, I mean sigma ni. So the first price is 50 and the number of books is 5. The second price is 45 and the number of books is 8, and the third price is 60 pounds and the number of boxes or the sample size is 7. Okay, so the summation of these multiplications will be 1030 divided by 20. So 20 is the summation of all sample size. The combined mean here is 51.5. Using MATLAB, as we did in case of weighted mean, we have to use the same way to compute the combined mean. So combined mean equal sum of n multiplied by x bar divided by sum of n. X bar equal 51.5, right? Okay, so the combined mean looks like the weighted mean. Number 4, trimmed mean. Okay, the trimmed mean is very useful as a measure of location or central tendency when the ranked data set mean is computed by eliminating or dropping a specific percentage of the ordered or ranked observations from each end of the data set. Okay, so when you use the trimmed mean, when you have to use the trimmed mean instead of the mean, okay, to compute the trimmed mean by computer program, MATLAB program, you have a function trim mean, okay, mean excluding outliers, okay. What's the syntax? What is the syntax of computing trim mean? M equal trim mean x and percent, trim mean x and percent, and dim description M equal trim mean x and percent calculates the trim mean of the values in x for a vector input. M is the mean of x excluding the highest and the lowest k data values, where k equal n star multiplied by percent divided by 100 and divided by 2. Okay, and where n is the number of values in x for a matrix input, M is row vector containing the trimmed mean of each column, as we said before, of x. Percent is a scalar between 0 and 100. Percent is a scalar between 0 and 100. Okay? The syntax trim mean x and percent and them takes the trimmed mean along the dimension them of x. Okay, so example 5 will illustrate the way for computing the trimmed mean. The following data give the expense of 10 students in 1 day by Egyptian pounds. Okay, the first row represents the 10 students, and the second row in this table represent the expense, or you can say the pocket money of every student. Find the 10% trimmed mean. Here, the 10% trimmed mean means get the mean for only 80% of the data set and omit 10% from the right side and 10% from the left side after ranking the data set. Okay, so you have to use trimmed mean if your data set include some outliers in the right side and some outliers in the left side. In this case, you cannot use the mean, but you have to use the trimmed mean to omit the outliers or the extreme value and the two sides of the data set. So the solution by hand will be: first step, the ranked data or the ordered data for from small to large will be begin with the smallest observation and the greater and so on. Okay, so you have to rank all observations from small to large as this row. Okay, after dropping 10% from the two ends, the remaining ranked data will be like this. So we omitted the observation value 75 from the right hand and the observation value 15 in the left hand. The remainder of the data will be 8 observations like this, beginning with 24 to 55, right? So we have to omit 10% from the right side and 10% from the left side. The mean of the remaining 80% will give the 10% trimmed mean. Okay, so 10% means omit 10 from the right side and 10 from the left side and compute the mean for the remainder of data set. Trimmed mean denoted by Tm equals the summation of the 8 observations divided by the number of these observations, which is 8 also. Then the trimmed mean will be 39. By MATLAB, using the function trim mean and total percent of the two ends we have. Okay, so put x equal all the data, the 10 observations, and put the command or write the command tm equal, the function is trim mean. This is a function, trim mean, and open the square x and 20. 20 here means omit 10% from the right side and another 10% from the left side. So the summation of the two omitted data is 20%. Okay, so trim mean here is equal 39, like we computed before by hand or using manual solution. Okay, example 6. The following data give the prices in thousands Egyptian pounds of 20 flats sold during the year 2016 at Port-Said City. So we have 20 flats written here, the price written here, using thousands. So the first data here is 185,000, the second is 295,000, and so on. Find the 20% trimmed mean of this data using MATLAB. So the manual solution is not requested here. Solution by MATLAB. Now enter the data like this. Okay, then use the trim mean X and 40. Look here, find the 20% trimmed mean. 20% here means that omit 20% from right side and other 20% from the left side. When computing the trim mean using the MATLAB program, add the 2% to each other, so 20 and 20 equal 40. Okay, so 40 is a summation of the omitted percent you want for the two sides of data set. Here trim mean is 360.83 approximately. Okay, the fifth measure is geometric mean. This is another measure of central tendency when the data set in the shape of or in the form of ratios. Okay, so when the data related to studying some phenomena such as inflation or population changes during a period of time, which include periodical increase or decrease, the geometric mean is employed to get the average change over the entire period under study. To compute the geometric mean of the sequence of n values, x1, x2, and extra, we get the product of multiplying them together and then find the nth root of this product. Thus GM equal the square root of the nth square root of the product xi, where I equal 1 to 2n. Or you can say that GM equal x1 multiplied by x2 and so on to the power 1 over n. So the power 1 over n means the nth square root the nth square root. So this is another formula. The third formula, as you see, is the nth square root x1 multiplied by x2 and so on, where GM is the geometric mean. When using the MATLAB program, we have the function geomean, geometric mean. The syntax is m equals geomean of x, and the second syntax is m equals geomean of x and dim. Description: m equal geomean of x, calculate the geometric mean of a sample for vectors geomean x is the geometric mean of the element in x. For matrices, geomean of x is the row vector containing the geometric means of each column. Okay, and so on. Or this syntax looks like the previous syntaxes. Example 7. Assume that the inflation rates for the last 5 years are 5%, 7%, 8%, 9%, and 10% respectively. Find the suitable mean of price indices and inflation rate over the 5-year periods. Solution: by hand, the geometric mean of price indices is GM equal 1.05 multiplied by 1.07 multiplied by 1.09 multiplied by 1.08 and finally multiplied by 1.1 to the power 1 over 5. 1 over 5. The result is 1.07 as you see. So the mean of inflation rate will be 1.07 minus 1 equal 0.0779. So the rate of inflation according to geometric mean will be 7.8 more or less. Okay, so here when computing the average inflation rate, you have to use first the geometric mean, second put 1 in addition to the inflation rate to get the index number after the inflation, okay, and subtract 1 from the result to get the changes of prices or the inflation rate, right? So when using a data set in form of rates or ratios or percent, you have to use the geometric mean instead of the mean. By MATLAB, using the geomean or nth root or broad functions we get. Okay, so we have 3 functions to compute geometric mean, but geomean is the better or the best function to use here. Okay, so in short and broad, just to learn yourself another functions to compute the zooming, but we have directly a function to compute the zooming. Okay, so x equal 1.05, then 1.07 and extra, n equal length of x. Then use the syntax zoom in of x to compute the index number for these data. This is the index number. Okay, using broad or in-throat, you can use another ways, another functions, but the inflation mean will be and GMI, which is the index, minus 1 equal 0.07 means 7.8%, right? Okay, so we will stop here at harmonic mean, and we will explain the harmonic mean and the other central tendency measures in the next lecture, inshallah. Good win, and see you in the second lecture. Have a nice time and stay at home for all the 2 weeks. Okay, thanks a lot and see you later. Okay.